Well, hello and welcome to today. We're going to begin our discussion on circles, parts of the circle, and again, how to graph circles. So if you'll remember that the center of the circle is just as it sounds, it is in the center. You have your radius, which is half of your circle, and your diameter is all the way across your circle. And so we know the fact that diameter is 2 times your radius. So that's just some, again, vocabulary words just to review. Now, when we talk about graphing on the coordinate plane, we're going to start talking about when it is centered at the origin and then when it is not centered and is just translated. So let me go ahead and give you your equation. So the basic equation in standard form for a circle is x squared plus y squared equals r squared. So if I have a circle that is x squared plus y squared equals 9, then that would mean that my center was at 0, 0, and my radius is 3. So when I go to draw that circle, again, my center is at 0, 0. My radius is 3, so I can draw a radius over to the right 3, then up 3, another radius, left 3, and down 3. Now, of course, doing the other ones would be a little bit more difficult, but then I'm just going to go in and sketch a circle the best that I can on there. I usually kind of do a little dot on there and then maybe go back in and fill in. My little marker here is not doing the greatest today, but then I go back in and fill with my circle and just get it as close to what would look like a circle as you can. The other way to do it, of course, if you have some kind of object that would work also, if you've got a compass, that would work if you wanted to, but I don't ask you to do it that detailed. Okay, so that would be if it's centered at the origin. Well, what happens if it's not centered at the origin, that it is actually translated off? It actually looks very similar to our parabolas, and we do h, that needs to be a minus, h and k, just as we did before. But we have both of them now squared, still equal to r squared. So before we had just our x that was squared, so this time your x and your y are both on the same side and squared. So an example of that is if I had something like x minus 2 squared plus y, we'll say plus 1 squared equals, I'll go ahead and use 9. And so what we're going to have on this one is we're going to have a center at 2, negative 1. Again, remember that the formula has a negative in it, and it has a radius of 3. So again, we go to 2, negative 1. And then from there, I just do my radius of 3. I just count over 3 to the right, up 3, left 3, and down 3. And if your radius happened to be a radical number, which you would get a decimal, that's okay. Just kind of estimate it the best you can. My circle here is not the best. That is a really bad circle. Yeah, a little bit better. Okay, so there's my circle. So that is a circle centered at the origin and a circle not centered at the origin. Now, let's talk about if we have an inequality. So we'll center one at the origin. And let's just do, we'll do less than or equal to 4. So again, it is center at 0, 0, and its radius is equal to 2. So I have my center, my 2, all the way around. Again, I'm going to draw in. Now this one it is equal to, so I do have a solid line. So it is solid. And if you put in 0, 0 here, you're going to get 0 squared plus 0 squared is less than 4, and that is a true statement. And so my shading will be inside of my circle. Okay, now circles are pretty easy because if it is a less than, it will always shade inside, and a greater will shade outside. Okay, let's do x plus 1 squared plus y minus 3 squared, and we're going to say greater than this time. We'll go ahead and go 9. So again, my center here is going to be at a negative 1, 3. I have a radius of 3. So I'm going to go to my negative 1, 3. I'm going to do a radius of 3, so 3, 3, 3, and 3. It is going to be dotted because it is just a greater than. So I am going to dot my circle. Okay, and then again, if you put, in this case, it's kind of hard to tell whether 0, 0 goes through it. It shouldn't really go through 0, 0. But you could pick another number. Let's just do an obvious one. We'll do 4, 0. Okay, and so in which case I would have 4 plus 1 squared plus 0 minus 3 squared, and is that greater than 9? Well, 4 plus 1 is 5. 5 squared is 25. We already know that's greater than 9, and so that does work. So my shading will be outside of my circle, and so what I should do is just everything outside my circle. And this does look a little bit strange compared to what we've done before, but it is everything out here, okay? So that would be, and then technically also everything up here. So everything outside of your circle. So again, on doing inequalities with circles, if it is a greater than, it does always shade outside of your circle. So you can pretty much bypass the testing of 0, 0. Okay. Now I'm going to do one more just real quick for you. And let's see. Actually, that is the last one that I'm going to do for you. So you're going to graph. Oh, no, I guess I was going to do one more. I'm going to do a system for you real quick. And so we're going to graph 2 of them on the same. So I'm going to do x squared plus y. Let's see what I want to do. Let's go plus 3 squared is less than, make sure it fits on my graph. Oops. We'll go less than 9. And then we're going to go x minus 1 squared plus y squared, we're going to do it this way, is less than 16. That should work. Okay, so we're going to start with the first one. And again, its center is going to be at 0, negative 3, with a radius of 3. So that's going to be my first one I'm going to do. So 0, negative 3, radius of 3. Okay, it is dotted. Okay, it is less than, so I'm going to shade inside. So do make sure we can tell that your lines are dotted on there. And then I'm going to go to the next one, and so we'll do this one in blue. So it is going to have a 1, 0 with a radius of 4. So I'm at 1, 0, and I have a radius of 4. So 4, 4, 4, 4. Again, it is dotted. Okay, get that dotted there. There we go. And it is less than, so again, it's going to shade inside. So we're shading inside here. Now this is a system, okay? So I'll go ahead and kind of do it like that. So we're talking about a system. So again, remember, systems are just where you see both of them crossed. And so you would need to come in with another color and darken in your final answer. So technically my final answer is right here inside this, kind of looks like an eye inside here. Okay, so that would be my final answer. So you would need to be sure you bold that some way so that we know what you're meaning as your final answer. Okay, so that's how you do systems. So we're going to try these on our own paper and see how well you do. We'll be doing those in class, so you just need to watch the videos.